Yeah, all right. So, those of you who were not with us in class yesterday, we talked about the binomial distribution. Well, the idea here is this, is there are things in our lives where the probability of things happening, they're distributed a certain way. For instance, if I tell you I'm going to flip, not flip a coin, let's do something else. Let's do roll a dice. We had this one in class, but whatever. Roll a dice. And listen, pal, I either want to get a 2 or a 3. Mr. Grimm, there's a 1/3 chance of that happening. Yes. Every time you roll, literally every time I roll. So your winning for you is getting a 2 or a 3. What if you don't get a 2 or 3? Well, then you lose, pal. There's 2 outcomes, win or lose, success, failure. Okay. And so what we're going to see is this. In the binomial distribution, there are 2 mutually exclusive outcomes. Period. End of story. Win or lose, fail, succeed, pregnant, not pregnant, whatever. I don't know, whatever. Yeah, and so on and so forth. Now, what kind of pet do you have? Frog or not frog? Okay, whatever it is. Now, that's number 1. Number 2, the probability of success must remain constant. We talked about this yesterday. Another way of saying that is each time you play is independent. And then ahead of time, you're going to decide, hey, I'm going to play n times. Okay, we're going to have 6 kids, period, right now. But we haven't even gotten married yet. Well, we're going to have 6, okay? Or we're going to roll the dice 37 times. Dude, that's a lot. I don't care. We're doing it anyway, pal. We're not quitting partway through. We're not quitting after we win so much or lose so much. We're going to keep going because we said we're doing 37, and that's what's up. All right? Now, so we talked about in class, P is the probability of success. Probability of success. Because, of course, that could be death. Probability of failure. That could be living. That's weird. P plus Q equals 100%, obviously, yes? Now, X is the number of wins or successes, I guess you would say. Success. Let's do successes. Successes. Nice. And then N is the number of times we play. Okay? And so our formula ends up being this. The probability that we get X is equal to N choose X, P to the X, Q to the N minus X. This is referred to as the binomial probability density function, or PDF for short. That's it. That's it. That's it, Groom. That's it, bud. So listen. Hey, listen. We're going to roll 16 times. Roll 16 times. What's the probability? Probability we get 2 or 3 4 times. I don't know. In other words, probability 2 or 3 4 times. All right, I don't know. Let's find out. So it's going to be what? Well, we're going to roll 16. So 16 choose 4. And then it's going to be 1/3 to the 4th power, 2/3 to the 12th power. How do I know it's 12? Because I had to lose the rest of the times. You see that? Silly goose. Now, on your calculator, I'm going to use Excel or Giggle Sheets. Either one. It's all the same, bro. It's all the same. So I'm going to go equals combin. Equals combin 16 comma 4. And then, times parentheses. Parentheses 1 divided by 3, parentheses to the 4th power, times parentheses 2 divided by 3, parentheses to the 12th power. Bam! 17% chance of happening, bro. That's it. Okay. Now, some of you are like, I wasn't here yesterday. Can you explain why? I'd love to. If I was going to win 4 times, I'd have to have a win, and a win, and a win, and a win, and then a loss, a loss, and a loss, ... 12 of these guys. Yes, that true? But listen, those could be in any order, hence the combinations. Are you with me? That's how many different ways you can sort these guys out. All That's all it's saying. Okay. So binomial PDF. Mr. Groom, we did this one yesterday in class. You are a 62% foul shooter. Nice. Foul shooter. Mr. Groom, I'm gonna shoot 12 times. 12 shots. Nice. What's the probability that I will hit 4? I don't know. Let's find out. Probably not good. But I feel like 62% of 12 is like 7 point something. I feel like I should hit 7.5 shots or something. You know what I mean? 7, 8, somewhere in there. But 4 seems not great. But let's find out. 12, choose 4. And then 0.62 times, well, I want to win 4 times. 0.38 the rest of the times. Done. Oops. And so in the giggles here, we're going to go equals 12, choose 4. So equals combin. 12, 4 times 0.62 to the 4 times 0.38 to the 8. About 3% chance. In other words, hey, it's unlikely to happen. Why? Because again, 62% of 12, 0.62 times 12 is, we should have got 7.5 shots. So 7 or 8 would have been very likely, but 3 or 4 is not very likely because obviously I'm not expecting to pull that off. Now, today, what I want to really focus on today is this. Hey, what about the probability that we make less than or equal to, or another way of saying that is no more than 4 shots? Well, remember, this is the same as saying probability that x is equal to 0. Probability of 0 plus the probability of 1 plus probability of 2 plus probability of 3. Groom, that's a lot of work. Plus probability of 4. I know. Well, Corinne, here's what's going to happen, girl. We actually have a name for this guy. The probability that x is less than or equal to big X, where x is just a value like 4 or something. This is referred to as the cumulative density function, or in other words, the CDF. Nice. Groom, was there a shortcut to that? I'm glad you asked. Of course there is. So in Excel, you're like, Groom, equals bino dot dist. Oh, that's hot. What does it want to know? Well, it wants to know the number of successes. So I'm just going to do 4 out of 12, right? 0.62. Now listen carefully. If I put a 0 here, it says cumulative. That's a question mark. I say no. 0.0318. Wait, hold up, bro. I feel like that's what I got before. Dude. So when I plug this in, remember that's going to be x, comma n, comma p, comma 0 is the PDF. If I say 1, then yes, I want cumulative. That gives me less than or equal to. Give me an example, Groom. My God, I'm glad you asked. So watch me over here. I am going to come to this page over here because I feel like it. And this is I'm just going to start laying this out here just so we can kind of play along it. Oops, I'm going to go X. And I'm going to go, oops, not just X, dumbass. X, P of X. Nice. And then watch this, bro. 0. Watch me drag this down. By the way, I can only shoot 12 times. I can only have 12 wins if I'm shooting 12 times. All right? Oops. One more time, Jay. One more time. There they are. I'm shooting the ball 12 times. The most I can make is 12 for 12. All right? So equals combin. Check this out, dog. Combin. Parentheses. 12, comma. Oops, I'm sorry. Whoa. Yeah, 12, comma that guy. Yes. All right? Times. You ready for this? And so then ours was 0.62 to the this guy times 0.38 to the 12 minus this fella. Oh, what are you upset about now? Oh, yes. Thank you. Thanks, Betsy. Oh, dude, look at that. Look at that. Friends, check this out. Equals sum. Let's add those guys up just for fun, shall we? Whee! 1. No way. Now, no way. Yeah, well, obviously, duh, stupid. Now, watch this. What if I did the probability that x is less than or equal to big X? Well, you can't be less than 0, bro. So this is literally just going to be equals this guy. But for this guy, less than or equal to 1 would be the sum of these two dudes. Now, don't worry, there's a bit of a shortcut to this in a second. I want to show you this, okay? Paste it down. And look what happens. Eventually, it adds up to 100%, yes? Hey, what's probably I make no more than 12 shots out of 12? It's 100%, bro. It's 100%, okay? And so there it is. Now, what you can actually do is this. Equals binomial.dist. Now, watch this. The number of successes. Let's say I put in 0. Let's just say I put in 0. Just for fun, 0. Out of 12.62. Now again, comma, let's just say I hit comma 0. Well, I get this number over here. You with me? In this case, watch this. I'm going to be fancy about it. You with me? And I'm going to do less than or equal to. So, cumulative. Paste that baby down, and look what you get. It's the same all the way down. You with me? So this is called the CDF is less than or equal to. Now, give us an example. I would love to. Okay. Let's flip. Oh, I don't know. Should we flip coins? I guess. I hate coins, but let's do it. Flip coins. Flip coins. Let's flip 10 coins. What is the probability that I will get less than or equal to 7 heads? Like, oh, I don't know, Groom. Well, it's literally this. Less than or equal to 7 is going to be equals binomial.dist. And I want 7, 12, 0.5, 1. Boom, there's an 80% chance that I will get less than or equal to 7 heads. Yay. Groom, what if I said to you, hey, what's the probability that I get more than 5 heads? You're going to be like, Groom, this is not a CDF. You are correct, ma'am, sir. Good for you. What's the opposite of greater than 5? It is less than or equal to 5. Are you with me, friends? And what is this? Plus this has to have to 100%. Dog, this right here is a CDF because it's less than or equal to. You with me, bro? So over here, I'm just going to cheat. I'm going to copy this one, okay? If that's okay with you, I'm just going to cheat and copy that one. Bam. So I get 38%. So equals, now watch this, equals 1 minus that fella, about 61%. Because what we just did, if you're paying along at him, what did I say it was? I forgot what I said. 30. We said this was 38%. Plus this, which I have no idea what it is equal to 1. Now, if you minus this over there, lo and behold, you get basically 62%. You with me? Give or take, whatever. Nice. Now, that's an easy one. That's an easy one. Do another one, Groom. Okay, if you insist. Your prized piglet. She's a sow, though. She's a big old gal. And she is preggers. And somehow, some way, you decided that you're going to get a sonogram of her. Good night, she's chubby. She's great with children. Nice. And it turns out there are 12 piglets in there. Nice. Nice. What is the probability that you will get at least 4 girl piglets? Groom, I don't know. Yes, you do. At least is greater than or equal to 4. Yes? That's what that says. Groom, this is not a CDF. CDFs are always less than or equal to. You're like, oh, dude. What's the opposite of this cat? The opposite of that is less than 4. True that, homie? Groom, this is also not a CDF. Listen, if you have less than 4 girl piglets, what do you have? You have less than or equal to 3 girl piglets. Are you with me? because there's nothing between 3 and 4 because they are discrete. Piglets are discrete. You cannot have half of a piglet. So this guy right here is our CDF. So on this calculator, I just come in here like so, and I just type it in. Oh, look at this. What do you know? How many piglets did I say there was? I forgot what I said. I say 12? That's lame if I said 12. Bro, that's lame. Oh, it's lame. Dude, it's lame. Okay, I don't care. I don't care anymore. So we're going to put 3 in here. Why are we putting 3 in here? Because we need less than or equal to 3. Okay, so it's 7%. And then, of course, it's 92.7% over here. So this is about 7%. So 0.93%, or 93% rather. And you're home free, friends. Okay? Can you use Excel? Mr. Graham, can I use Google Sheets? Of course you can use Google Sheets. Well, I mean, some teachers are jerks to us. I understand that, but that's not what I'm saying. Okay? You're going to be able to use it, obviously, in class. Mr. Graham, what's the probability that your sow has exactly 8 girl piglets? Whoa, Groom, that's a PDF. Why? Because of the word exactly. So I'm literally going to come into here and go equals binom.dist. What just happened here? Equals binom.dist. There you go. And I wanted how many? 8. You with me? Comma 12, comma 0.5, comma 0. There's a 12% chance that you're going to have 8 girl piglets out of 12. That's it. That's it. Okay, the boy piglets or the girl piglets. There's nothing in between. Yay. Discrete and mutually exclusive. That is your one or the other. It's binomial. Groom, what would happen if we let it have more than 2 outcomes? It's a different distribution, but you get the point, yeah? Groom, what would happen if they weren't independent every time I played? I don't know. Well, that's not true. I know. I'm going to tell you in a couple of days. But it's a different distribution. Are you with me? Groom, what happens if I play until I win or something? Oh, I don't know. That's not true. I know. It's a different distribution. You see what I'm saying? So we're going to shake this up. We're going to do it a little differently here and there. It's going to be a lot of fun. In the next few days, you're going to learn several other, like 6 total distributions. I'm kind of pumped about it myself. I'm just saying. I'm not saying, I'm just saying. You know how it is. What the kids say.